In this lesson, we're going to be covering rational inequalities. So we already went over polynomial inequalities, but now these are going to be similar problems, but with a rational. So the problems that we're going to be covering in this video can be solved either graphically or algebraically. So we're only going to be doing 3 examples, and we're going to learn how to solve each one in 2 different forms. And it's going to be up to you which form you decide to use, what method you prefer, and you could just stick to that one. So this is what we're going to do. We're going to go ahead and start by seeing how we can solve a rational function or a rational inequality by graphing. So what we're going to do is step 1, we have to make sure always that the right side is a 0. Once the right side is a 0, then we're just simply going to graph whatever we have on the left side, which in these problems are going to be rationals. And then we're going to have to identify the intervals that satisfy the inequality. So if we have a greater than symbol, we have to remember that a greater than or greater than equal to represents where the graph is above the x-axis. A less than or equal to represents the piece or the interval where the graph is below the x-axis. So it's very important that you remember the meaning of these symbols, and that's what you're going to be doing. So you're just going to graph, stare at the graph, analyze it, and find your answer depending on where the graph is above or below the x-axis. Now, if you prefer to solve it algebraically, this is what we're going to do. So step 1, just like in the previous method, you always have to make sure that the right side is equal to 0. Step 2, on the left side, you're going to have a rational. So you're going to set both the numerator and denominator equal to 0 to find what we call our boundary points. Step 3, you're going to create a number line with the boundary points. And again, it's very important that you remember when you make a number line, the boundary points have to be listed from least to greatest. And then step 4, you're going to test a point in each interval to see which intervals satisfy our inequality. So before we actually tackle some problems, let's just go ahead and look at one more thing. Earlier, we already learned how to find the domain of a rational, and it's going to be very important in these problems because our final answers cannot include values that are excluded from the domain. So all you have to remember is that any value that's excluded from the domain is always going to be in parentheses. Okay, so from previous videos, we've learned that infinities always go with parentheses, but now when we're solving a rational, we have to remember that any value that is excluded from the domain, or in other words, that comes from the denominator, is also going to have parentheses. Okay, so let's dig into our first problem here. We have a rational. It doesn't have an inequality, but they tell us on the top, right? They ask us to solve this inequality for when it's greater than or equal to 0. So each of the problems we're going to be working on today, we're going to start by solving them graphically. So since we already have a 0 on the right side, which technically is not on the problem itself, but they are telling us it has to be greater than or equal to 0, we could go straight and graph this. So you can use a graphing calculator, but I highly recommend you use decimals.com. Again, Decimals is a graphing utility that's on a website, and it's really nice because you can actually click on the x-intercepts and it will give you the points. So I went ahead and graphed this. Again, if you need help with decimals, please let me know and I'll guide you through it. But it's pretty straightforward. So you go to decimals.com, you put this in order to graph it, and it gives you this graph. Obviously, the answer is not here, but you just have to interpret the graph. So I'm going to go ahead and draw something here. And you're going to notice that my graph is, in some part, it's above the x-axis, and in another part, it's below the x-axis. You have to remember that this symbol right here means that we are going to need to look for where the graph is above the x-axis. Remember, the symbol is greater than or equal to. So what I'm going to do is I'm just going to try to see where the graph is above. So here we have negative infinity. So from here to here, the graph is above. If you notice, it's always above. So from here all the way to, not there, sorry, till my asymptote. So let me go ahead and erase that. Let me just start again. So from negative infinity all the way to my asymptote, which is right here. That asymptote is it's positive 1, right? So my asymptote goes all the way to positive 1. And then from here to here, so the graph is above in this part. And then the graph here is below all the way to this intercept, which is 7. I'm going to come here. And from here to here, it's below. And then from the 7 forward, the graph becomes or turns into above the x-axis. So actually, those are my answers from negative infinity all the way to positive 1. Because again, that's the asymptote right there, and the graph, that's where it's above. Starting from 1 to 7, the graph is below, so we disregard this. And then from 7 all the way to positive infinity, the graph is above. So look at that. That's actually my answer. But before we actually write our answer, remember what I told you earlier. The domain always has to be excluded from the answer. So my answer is going to be negative infinity to 1. But if you notice, make sure you put a note of that. We had to use a parentheses here because, like I told you earlier, any value that's excluded from the domain has to be excluded from the answer. So we put a parentheses. This number here has a bracket because obviously we have already learned that every time you have an equal to on the bottom, you always use brackets. And then the infinities always go with parentheses. Okay, so if you found this confusing, let me just go over it again. Infinities always go with parentheses. The numbers would normally go with a bracket because of the equal to on the bottom, so they would both be brackets. But then we come back and ask ourselves, okay, the one cannot have a bracket because it's excluded from the domain. If you need help with the domain, let me know, but it is from a previous video. Remember, the domain always comes in the denominator. So that one is going to have a parentheses. And that's it. That's my answer. So I was able to grab my answer just by staring at the graph. Okay, now if you found this a little bit difficult, we are also going to learn how to solve this problem algebraically. So if you prefer to solve this problem algebraically, again, we're going to follow the same steps. Step number 1, you have to make sure that we have a 0, which we already have. Step 2, you're going to set the numerator and denominator equal to 0. So I'm going to set the numerator equal to 0, and I'm going to get x equals 7. That's going to be my first boundary point. And then I also set the denominator equal to 0, which I get 1. And that's also going to be a boundary point. And when I'm doing this algebraically, I always like to remember that I put a little note that, hey, this is your domain. So obviously this one's going to go in parentheses. Okay. The next step is to put these numbers in a number line in order. So the 1 comes first and then the 7. And then I create my intervals and then I test points, right? We've done this before with polynomial inequalities. So I'm not going to go very much in depth into it, but it's the same thing. So my first interval is going to be from negative infinity to 1. And again, I know this symbol means we're going to use a bracket, but when we're dealing with rationals, whatever number came from the denominator has to have a parentheses. So from negative infinity to 1, I chose the number 0, and I put it in the original equation. So I put a 0 on the numerator, 0 on the denominator, and end up with positive 7, which is greater than or equal to 0, because remember, that's what we're looking for. So this is going to end up being one of my answers. Okay. My second interval is from 1 to 7. Again, the 1 has a parentheses because it's from the domain and from the denominator. And then the 7 goes with a bracket because obviously that's the sign. So from 1 to 7, you can choose any number that you want. I chose 2 and I substituted to the problem. You can do the math on your own, but I ended up getting negative 5. Since it's a negative number, this one is not greater than or equal to 0. So this is not going to be one of my answers. So we found 1. This one's not. Let's check the next one. The next interval is going to be from 7 to infinity. I chose 8, substituted into the problem. I got 1 over 7. I really don't care. I just care about the sign. Since it's positive, it is greater than or equal to 0. So that's one of my answers. And then just as a reminder, when you have multiple answers, you unite them with a little u in the middle. Okay, so there you go. We found 2 different ways to solve the same problem. Regardless of what method you prefer, just make sure that for assignments, for written assignments, and for your tests and any exam that we have in this course, you do have to show work. So if you prefer to do it graphically, make sure you write down a picture of the graph. And if you prefer to do it algebraically, of course, just show all your work. And regardless, you're going to end up with the same answer. All right, we're going to go ahead and try 2 more examples. Let's go ahead and try this one out. Again, we're going to do it both graphically and algebraically. So if I want to solve this graphically, we have to make sure we have a 0, which we already have, and then we just simply graph it. Okay, this is a little more intense graph, so let's see if we could figure it out. First thing we do is look at the symbol. This symbol is greater than, so that means we have to also look for where the graph is above. So here we have negative infinity all the way to the asymptote, which is at negative 5, 6, negative 7. Here the graph is below, so this is not going to be one of my answers. Starting at negative 7, all the way to, again, this is tempting, but the actual y-intercept is, the actual x-intercept is right here at 4. From here to here, the graph is always above the x-axis. Okay, so I'm going to chop the graph right here. This is going to be one of my answers because the graph is above from -7 to 4. Actually, I'm so sorry. This is -8. I just counted wrong. 5, 6, 7, 8. Sorry about that. So from -8 to 4, the graph is above. Okay, let's keep on going. From 4 to this vertical asymptote, 5, 6, 7, 8. This is also an 8, but a positive 8. From here to here, the graph is below the x-axis. So this is not going to be one of my answers. But then if you notice from 8 all the way to positive infinity, the graph is above. So this is my second answer. Okay, so there's not many calculations or algebra involved. It's just you having to analyze the graph. So my final answer is going to be from -8 to 4 and from 8 to infinity. Now, brackets or parentheses, remember this sign doesn't have an equal to on the bottom. So super simple, just remember everything's going to go with parentheses. So everything, the infinities, the numbers that come from the domain, the numerator, everything's parentheses. So again, since it doesn't have the equal to on the bottom, parentheses everywhere. Just like I said before, we're also going to solve this one algebraically. So if you're still a little confused with the graph, maybe you prefer to do it by hand, moving things around, you could do that as well. So again, same thing, we have to have a 0 on the right side, which we already do. And if you notice, all the problems we're going to be doing today, they have a 0 on the right side. Eventually, we're going to tackle some problems that don't, but for right now, we're going to keep it simple. So in order to solve this algebraically, we're going to set the numerator equal to 0, and I'm going to get a positive 4, which is going to be my first boundary point. And then I'm going to set the denominator equal to 0. If I set the denominator equal to 0, I move the 64 to the right side. I get x squared equals 64, and then I apply the square root of both sides. And then remember, when you do the square root of both sides, you have to put a plus and minus in the front, giving me 2 answers. The square root of 64 is 8. I'm going to have a positive and a -8. And just like I told you earlier, when you solve the denominator, remember, these are the numbers that have to be. So when you give me your final answer, those would have to be in parentheses in case you would have brackets in the problem. So let's go ahead and do this algebraically. I'm going to create my number line. From least to greatest, I have the -8 first, and then the 4, and then the positive 8. And then we just test numbers. So my first interval is going to be -infinity to -8. Again, because we don't have an equal to on the bottom, they're all going to have parentheses, so I don't have to worry about brackets at all. I chose -9. I substitute the -9. If you're going to substitute a negative in and then square it in your calculator, make sure you put parentheses. So again, I don't care what the number is. I just care that it's a negative number. So obviously it's not going to be greater than 0. So this is not going to be one of my answers because we're looking for numbers that are greater than 0. And then I just keep on going. In the next interval from -8 to 4, I chose 0. I substituted, I got a positive answer, which is greater than 0. So that's going to be one of my final answers. Next interval is from 4 to 8. I chose the number 5, substituted it, and I got a negative number, which is not greater than 0. So that's not going to be one of my answers. And then the final interval is from 8 to infinity. I chose the number 9, substituted it into the original equation, into the original inequality, and I got a positive number, which is greater than 0. So those would be my 2 answers. And again, it's the same answer from the previous problem, but you have 2 methods of writing it down. So for your notes right now, please include both methods. But from written assignments from now on, you get to choose which method you prefer, and you could stick to that one. Okay, so let's go ahead and try one last problem here. In this last problem, we have, again, an inequality with a rational. And we're going to try to do this graphically. So we have to have a 0 on the right side, which we already do. So I just put this on decimals, and then I graph it. So remember, every time you have an x-intercept or an asymptote, it's a natural break in the graph. So here, they're asking us to find numbers that are, I'm sorry about this, distance of greater than or equal to, which means that we need to look for where the graph is above again. So where is the graph above the x-axis? So let's just go ahead and start. We always start at -infinity. From here to this x-intercept, the graph is below. So this is not going to be one of my answers. And then we have from -12, the graph is above. Obviously, we can't see it, but it goes above all the way to my vertical asymptote, which is at +1. So from here to 1, the graph is above. So this is going to be one of my answers. From 1 to 4, because remember, that's an x-intercept. The graph here is below. And then from 4 to infinity, the graph is above. So we have 4 intervals in this graph, and we just want the above. So it's going to be from negative 12 to 1. And then my second answer is going to be from 4 to infinity. But before we actually write our answer, remember, we have to see if we're going to use brackets or parentheses. So this symbol has an equal to, meaning I'm going to have to use brackets. But remember what we said earlier. You have to look at the domain. We cannot include a bracket on the 1 because the 1 is excluded from the domain. It comes from the denominator. So my answer is going to be, like we said earlier, negative 12 to 1, bracket, because that's what the symbol says up here. Here we would also have a bracket, but since the 1 is excluded from the domain, we have to put a parentheses. Union, the 4, which is going to have a bracket because, again, it's a number. And then all the way to infinity, and we know that infinities always go with parentheses. Okay, so there we go. That's our answer. And again, just in case you don't prefer this method, we're going to do it one more time, just solving it algebraically. So again, the same procedure. We have to make sure we have a 0 on the right side, which we already do. And then we set our numerator and denominator equal to 0 to get our boundary point. So I go ahead and start with the first parentheses of the numerator, which is x plus 12 equals 0, and I get x equals negative 12. The second parentheses gives me x equals 4. And then the denominator gives me a positive 1. And again, I love to put a little note for myself telling me, hey, this comes from the domain, so this is going to be excluded from our answer. Okay, so those are my values. Just as a reminder, if the numerator would have not been factored out, you would have to factor it out to make it into parentheses. And again, we're masters in factoring. So this would have been a trinomial. I would have to find 2 numbers and multiply to AC, and they add to B. And then you would factor it out and then set them equal to 0. But this one's already nice and factored out for us, so we just equal them to 0. So my boundary points are 3. In order from least to greatest, I'm going to have the negative 12, the 1, and the 4. And then I just create my intervals. So my first interval is going to be from negative infinity to negative 12. Again, we're going to put a bracket on the negative 12 because the sign says so, and because it comes from the top, which is okay. I chose the I chose the number negative 13. I substituted into the x's, just like I did here. And again, I really don't care about the decimal. All I care about is that I got a negative number. So negative is not greater than or equal to 0. So this is not going to be one of my answers. And then we just keep on going. My next interval is negative 12 to 1. And again, negative 12 with bracket because of the symbol. And the 1, I would use a bracket because of the symbol, but then I remember, hey, the 1 came from the denominator, so it cannot be included. So I put a parentheses. From negative 12 to 1, I chose the number 0. So I substituted in. I got a positive answer, so it is greater than or equal to 0. So this is one of my answers. And then let's just keep on going. From 1 to 4, I chose the number 2. Substituted into the original problem. I got a negative number, which is not greater than or equal to 0. So I do not include it. And then my last interval is from 4 to infinity. So I chose the number 5, substituted into the problem. I got a positive answer, which is greater than or equal to 0. So that's my second answer. And the proper way to write this is the first interval that worked, union with the little u, and the second interval that worked. Okay? So just like I said throughout the whole video, you have 2 different methods of solving the problem. You don't have to use both methods. In your notes right now, make sure you are writing all the work for both methods, but from now on, for any written assignment, including your midterms or any written homework or quizzes, you can choose what method you prefer, but just make sure you show your work. So if you prefer to graphically or to solve it graphically, make sure you draw a graph, and then I could see how you got the answer from the graph. If you want to do it algebraically, just make sure you show all your work, your intervals, and your testing points. So pretty much, again, just make sure you show your work and you'll be okay.